using the complement rule for probabilities. First, what is a complement? Well, when we're talking about probability, we are talking about an event not occurring. So the complement of an event is like basically the opposite. So if the event is the probability of A, so the event is A, then the complement, we call it A prime, or everything that is not in A. So we could say A and not A, literally everything else. Okay, so one thing to kind of keep in mind is that if we talk about the event and the complement, this is literally all options, right? Because the event is A and the complement is not A. So if we put them together, we are going to get 1. Because remember, when we total all probabilities for something, we get 1. Now that also means we can take, or we can say that the probability of A prime is 1 minus the probability of A. We could also say that the probability of A is 1 minus the probability of A prime. Meaning, if we know either the event or the complement, we can use one of these two formulas to find the other. Because sometimes you might need the complement, but it's a whole lot easier to just find the event, or vice versa. Okay, so depending on what we have and what we need, that is kind of how we work there. So you roll a 6-sided die. What is the probability you do not roll a 3? And you might say, well, this is kind of an easy one. Work with me with the process. If I'm rolling a 6-sided die, I want the probability of not a 3, right? So 3 prime, everything that's not a 3. Well, easier way to do it is to say, well, what is the probability of rolling a 3? Well, it's a 6-sided die, and there's only one 3. So the probability of 3 is 1/6. So I know that 1 minus 1/6 gives me the probability of not 3. Well, 1 minus 1/6 is everything else, so the answer is 5/6. So the probability of not rolling a 3, or 3 prime, as we like to say, is 5/6. Right? So that's kind of the idea, that you can find the probability of the event and then use the equation 1 minus the event, right? 1 minus the event gives us the complement, which is then what we found here. So let's do another. A flight between two cities is on time 92% of the time. If you book a ticket on this flight, what is the probability your flight will not be on time? Okay, so right now I know that the probability of the event is 92%. And the event is being on time. So the probability of being on time, let's go ahead and change that percent to a decimal and make that 0.92. So that means the probability of not on time, or we could say the probability of on time prime, is 1 minus 0.92. So that gives me 0.08. So the probability that we are not on time is roughly 8%, right? Because it's everything else. If it's on time for 92%, that means it's not on time for 8%. And that's the idea of dealing with complements.